In this problem, we're finding the exact values of a couple of trig functions. Let's start with part A. So in part A, we're given the hint that 11 pi over 12 is the same thing as 2 pi over 3 plus pi over 4, which would suggest that we can solve this problem or find the exact value by using the angle sum formula for the sine. So the angle sum formula for the sine says that we take the sine of the first angle, 2 pi over 3, times the cosine of the second angle, pi over 4, and then we add to that. So for the angle sum formula for the sine, the plus on the inside corresponds to the plus on the outside as well. So we add to that the cosine of the first angle, 2 pi over 3, times the sine of the second angle, pi over 4. Now it's a matter of reducing. Sine of 2 pi over 3 is radical 3 over 2. Cosine of pi over 4 is radical 2 over 2. And now we get to do the reverse. So cosine of 2 pi over 3 is negative 1/2. And the sine of pi over 4 is radical 2 over 2. And if we want to reduce that, the common denominator will be 4. And the first numerator is radical 3 times radical 2. So radical 6 minus radical 2 over 4. In part B, we want to use a double angle formula to find the cosine of 2 theta. Cosine of 2 theta is, one way to define it is cosine squared of theta minus sine squared of theta. So if we know what the sine of theta is, or the cosine of theta, we know how to find the cosine of 2 theta. We're given sine of theta is 4/5, which means that if we want to find the cosine of that angle theta, we can draw a triangle. There's theta. The opposite side is 4. The hypotenuse is 5, which means that this other leg of the triangle will be the square root of 5 squared minus 4 squared, or 3. And so the cosine of this angle is the adjacent side, 3, over the hypotenuse, squared, minus the sine, which is 4/5 squared. And if we reduce this, is 9 over 25 minus 16 over 25, so negative 7/25.